Hi, everybody. All of you who've eaten your lunch, everybody, great to see you. I'm Prabhu. I have a very long name, but I go by Prabhu. I am from Meta. I'm a director of product. I work on Llama. We also have Anusha, who's a partner engineer at Meta. I'm the warm-up act for this session, to be very honest. She's going to tell you all the cool stuff. She's going to tell you the kinds of things that make a difference in your business. I am the salesy guy. I'm going to tell you some cool stuff, but really, you should wait for her, not for me. Okay. I'll do probably a few minutes of talking about Llama, just to context set for everybody. I'm pretty sure every one of you here knows what it is, otherwise you wouldn't be inside this room. But she's got actual code to show you, she's got tools to show you, and that's where all the fun stuff is. All right, how many of you here are engineer types, and how many of, or maybe I'll ask this question, how many here are people who do non-engineering stuff? Not bad, not bad. Okay, you have some people like me, right, who earn their keep without actually doing the cool stuff. Great. All right. As I said, I'm Prabhu. I'm a director of product on Llama, and I'm going to talk to you about our models. All right, so agenda for today, super quick overview, super quick run on Llama 4, a little bit of time on model selection because I think that's important. And then obviously the meat of all of this, which is how do you get the most out of it. Okay, let's talk about Llama. It's been a crazy ride. If you think about the fact that Llama is just over 2 years old, it boggles my mind. Personally, when you think about this, GenAI itself is fresh and new. Here we are at the Databricks AI Summit, many thousand people talking about not just models, but we have multiple layers of the stack that has now been built on top of generative AI. It's kind of crazy. Businesses have been built. Businesses worth hundreds of billions of dollars. It's just insane. So just from a context standpoint, if you think about Llama, we started with Llama 1, which was a 7, 13, 34, and 65B set of models. We kind of grew. The most popular ones, I think we can all agree, is the Llama 3 line. This is when we started hitting, I would say, escape velocity. This is your 8B and the 70B models, which continue to be super popular to date. Then we started iterating on those models. There's a 3.1 version of 8 and 70, and then there is the 405B, which many businesses have used for a lot of internal reasons. Then we started doing Llama 3.2. This is when we brought vision models into the mix, and we also started building the on-device models, both of which address a set of very important use cases. And then we iterated on the 70B with the Llama 3.3 line. And then obviously earlier this year we did Llama 4. We'll talk about Llama 4 in a little more detail. It's been kind of crazy, lots and lots of models, and a lot of people are using Llama. How many people? That 1.2 billion downloads is already out of date. Llama models get downloaded at a crazy clip. And here's the interesting part, right? Downloads are not just the only way by which people consume Llama, which kind of tells you how big this thing is. People use APIs to use Llama. People download the models. And once downloaded, some of you are probably part of enterprises where somebody downloads a copy of Llama, you fine-tune it for some particular use case, and then it's just being used internally by many hundreds, if not thousands of people. So the footprint of Llama is pretty remarkable in ways that even we don't fully comprehend. And when you think about derivative models, and these are just the ones that get registered with us, that's also an insane number. Again, 2-year-old thing, and I'd argue most of these derivative models are of Llama 3 and beyond, which means many of these derivative models are probably just over a year old. And again, this number is I'll tell you an inside joke from Meta. I know the number of the derivative models, And I went to our team and said, hey, we should publish this. But then they said, oh, we need to go through a stat review to confirm that these numbers are right. So I'm like, okay, I will share the last publicly shared number. And this is kind of the scale at which not just Llama, but generative AI more broadly is printing, which is things are just everybody is using this. And the reason why we talk about these numbers so proudly is because Llama lends itself to so much flexibility for all of you. I'd probably argue within the people here and within this very large conference, so many people use Llama in so many different ways, I wouldn't even be able to document that. And that's the beauty of open models, right? So you can deploy it on a CSP, VPC, on-prem, and these are just some of them. You customize it with so much fine-tuning. I've seen people fine-tune it in so many different ways. And I think that's the magic of building open source models. Some use cases, obviously, we are at the Databricks Summit, so we had to pull up Databricks. But by the way, Databricks is a great partner for Llama, so would love to give them a shout out. They do some awesome stuff with it. And then these are a couple of other examples. And again, hundreds of thousands of examples of how enterprises and businesses use Llama today. And again, I can't even wrap my heads around it. All right. In addition to that, all the ways that businesses use, there is one business that I'm very intimately familiar with that is using Llama extensively. That is Meta. Meta AI, which is our assistant product that you can access on WhatsApp, on Instagram, on many other surfaces, on its own app today, is used by more people than any other assistant. Over 1 billion people use this product every month and growing. People find different use cases to use Meta AI, and Llama is the foundation. So when we come to the world and say, hey, you know what, you should think about using Llama, it is because we know there are 1 billion people using it every month, and we understand the value of the model and thus the product. So let's talk about Llama 4. Llama 4 launched earlier this year. We made 2 models available. There's a third model that's cooking. Of the 2 models that are available, there is Scout, there's Maverick. They are similar models in the sense that they both have a similar number of active parameters, but they do have different number of experts, which means the intelligence of these 2 models are significantly different. Llama 4, Scout, all of our models at this point are all multimodal models. Scout is smaller. You can fit it into one H100 GPU. Offers 10 million context length. Great model. Maverick offers all the stuff that Scout does, much more intelligence, and larger model, of course. Let's talk about some use cases. Again, Anusha will go into a lot more detail. Long context is one that I'm generally fascinated by because, the more you can squeeze into the context window, it just means you can get more out of your model in near real time. So as you think about this, some of the use cases that we thought of and we heard from a lot of our partners in building longer context windows is legal document analysis, scientific research, financial analysis, multilingual analysis. I mean, lots of places where having a longer context window is just that much more meaningful. I think I have a video for this. Yeah, let's run this video. So this is a neat video where we use the context window to do something interesting, which is, actually, why don't you watch this? That pause. Yeah. So basically what you can do is you can now synthesize very large websites, very large repos, and we built an app to showcase that. And the value of having this large context window is now open for people to fiddle with. One of the questions that comes up, and again, I'm happy to talk about this when we are done with, is, hey, is longer context windows replacing RAG? This is a question that comes up fairly often. My personal opinion is that it doesn't replace RAG as much as it augments it, and there's always a value where RAG is the solution. But there's also now opportunities where there are some use cases where you had to use RAG that can now be done with having a longer context window. But we can talk more about that later. How can you get Llama 4? I'm pretty sure all of you have already seen it, but if not, Hugging Face, llama.com, or pretty much any provider where you get your models from. I want to spend a few minutes talking about building a model that works for you, because I think this is a very important topic. A year ago when Llama 3 was launched, there were not a lot of open source models. As a result, a lot of people jumped on the Llama bandwagon. Now there are choices, and you should obviously use the model that works for you. But it's also hard to choose what is the right model. So again, this is an unbiased view of model choice, and I wanted to put this in front of you because I think there is some value in having this conversation. You want to find models that are accurate, right? So accuracy obviously is super, super important, and depending on the use case, accuracy is either tantamount or accuracy is just important. So this varies not just on your business, but on your use case. Second, cost. If you are using a few 100,000 tokens or a few million tokens, cost might not add up. But as you build scalable businesses and you're going into the tune of billions of tokens, cost adds up really, really fast. The last part is latency. Again, if you're using passive asynchronous applications, latency is not that big a deal. But if I am having a chat interface where I am going back and forth with a model, if the model is going to take forever to respond, that kind of sucks. So depending on your application, depending on your use case, you are going to figure out how this triangle looks for you and how this prioritization looks for you. And how you think through this prioritization is then going to reflect on the kinds of models that you actually choose for your business. So this is just, all of these are charts from artificial analysis. If you're not familiar with artificial analysis, I assume everybody is familiar with artificial analysis. If not, great resource. I recommend everybody check out if you're interested in generative AI models. I would always say go to artificial analysis because they give you a good context of all the models that are out there. So if you think about this in terms of the vectors that I talked to you about, like you think about where Llama 4 Maverick is, how fast the models are, cost, and then intelligence versus cost. So why am I talking about all this? So let's talk about this. So today, intelligence, I think I showed you on top of that pyramid, intelligence is super important. Second, how fast those models are super important. In our case, and I'll talk about this, when we built Llama 4 Maverick, we first have to figure out how we're going to address the needs of the billion people who use Meta AI, because Meta AI runs on Llama 4 Maverick. So for me, latency is ridiculously important. I need these models to be faster than the previous generation models. So one of my requirements when I started working with the modeling team is, hey guys, we have to make this model at least as fast as Llama 3, which was powering Meta AI, if not faster. Super important. Cost, very important. Yes, we are Meta, but ultimately when you are serving something for a billion users, the costs add up, right? GPUs are not infinite, and we have to balance between serving customers versus training new models. So for us, we have to always be conscious of, are these models optimized so they are fast and they are cheap? And then obviously you want these models to be smart. Otherwise you can have the fastest models in the world, the cheapest models in the world, but if they are not smart enough, nobody's going to use it. So trying to find how to balance these needs and getting to that intersection point was the challenge in building Llama 4. People often think, hey, Meta build a model, good for me, not good for me. I often tell people, think of this in context of how and why these models get built. And the one other thing I will share with this audience is, reasoning models are all in vogue. So we all talk about the different reasoning models that are out there. I'm a big fan of reasoning models myself. I use reasoning models for some of my use cases. The challenge with reasoning models, especially as you're building businesses, is that reasoning models are extremely token hungry, right? Before you know it, you're spending a lot of money in using these reasoning models. The other thing about reasoning models is it takes time and a lot of smart prompt engineering to get to the answer fast. So while latency is not a factor, getting to the answer actually takes forever long, right? I use reasoning models all the time, and I'm like, the most frustrating thing is I'm like, yeah, I know you're thinking, get to the answer fast, right? So just figuring out what application needs a thinking model versus what application needs a non-thinking model, and factoring cost into that also makes a huge difference. So I hope you got some flavor for all of this. I've kind of bundled this as a parting chart. You'll notice all the non-reasoning models are cheaper and faster, and more importantly, take far less output tokens. And this matters depending on your business. Because eventually, if you are with whoever your favorite API provider is for tokens, this cost just multiplies very, very fast. So I hope I gave you some flavor for what the landscape is, our motivations for building the kinds of models that we do, why it's valuable, why it's interesting, and kind of where we are headed. I will now get to the more interesting part of the presentation, which is Anusha, who's going to talk about how you can actually squeeze the most out of your Llama models. Here you go. There you go.
Thank you, Prabhu. Hello, everyone. I'm Anusha, partner engineer at Meta. I help enterprises and developers like you achieve success with Llama on our partner platforms. So Prabhu so far walked us through the evolution of the Llama models and different models that are available, our latest Llama 4 models, and how these models perform across intelligence, cost, and latency. Now let's get into how to get the most out of these models. So before doing that, let's take a moment to understand why do enterprises and developers use Llama models in the first place. Prabhu covered it so well, but let's take a quick look. Cost, latency, control over customization and deployment, and data security. These have been always the top reasons why these models are so important for enterprises. And we have seen enterprises cut down cost by 10 times or 30 times when moving from proprietary models to open source Llama models. If you're thinking, yes, that's great, but my use case is so complex or they don't really work for me, so let's try and see if any of the problems we'll talk about that you identify with, and maybe some of the tools and techniques will help you solve for these problems. So here is the plan. So we'll look into what are the common issues that developers face, starting with you might have tweaked your prompt tens of times, but not sure, is this the right prompt that gets the optimal performance from these models? So how to systematically approach that? And then the model hallucinations, incorrect answers, not getting the desired style or ability to reason for the task, and you want to customize the model, and often you don't have the necessary data set to do so. So we're going to look into how to use some of these tools and techniques to address these challenges, starting with prompt optimization, techniques in RAG, synthetic data gen, and fine tuning. So let's dive into it, starting with our first problem. how to get the most performance with the right prompt. So just to cover basics, I'm sure all of you are already very familiar with prompt engineering, but let's quickly glance over it to cover the basics. So we give the AI a role and a specific task, write clear instructions, split these instructions into steps that helps the model think and reason better, and start with zero shot and then try giving some examples, which generally helps the model to output a better response, and test and revise the prompt. I'm sure all of you have done this multiple times, but the challenge is it requires experimentation, trial and error, and what works for one model may not always work for another. And migrating between the models is always very hard. So how do we systematically solve this problem? Introducing Llama Prompt Ops tool. This is a Python package recently open sourced by Meta. The tool takes in the prompt and a data set as an input. A data set is nothing but the examples of what is the input and expected output to the model. And the tool optimizes the prompt and returns a prompt that gives maximum performance for your target model. So here is an example. On the left, you see a pretty good prompt that is given as an input to the tool. The tool is still able to revise the prompt and also add few short examples, which seem to be working well to get great performance. So if you're curious how this performs on a real use case, so here I'm showing a hotpot QA data set, which is trying to solve for multi-hop question answering task, which is not an easy task, but as you can see, using the prompt optimization tool, we're able to achieve amazing performance gains, and as you can see, 3.370B is even outperforming the proprietary model. If you're wondering how to use the tool, it's pretty simple to set up. You can also run it on your Databricks environment in just 3 steps. Pip install Llama prompt ops, configure your config file. This has 4 sections. The model is basically your target model, and the data set, initial prompt that you can input to the tool, and the metric. The metric here basically helps the tool understand how should it match the response from the target model with the expected answer in your data set. Should it match it semantically, or should it exactly match, or do you have any specific custom criteria? So the metric can help the tool understand how to optimize for the response. So once you have your config file ready, Llama prompt ops migrate, the command outputs the file which has the optimized prompt. So hope this tool will help you to systematically optimize and migrate the prompts. Now let's dive into the next set of issues that developers generally face, where the model information is outdated, you're getting incorrect responses, and it does not have the knowledge of your domain, and the model hallucinates information. These are a set of issues where you expect the model to know something and return a factual answer, but the model is not able to do so. So let's call this the knowledge problem. So how do we tackle knowledge problem? So like Prabhu said, we can use long context, or we use RAG. So how do we? We fast. Okay, sorry.
You can slow down.
Yeah, thank you for that. Yeah, let me slow down. So yeah, let me cover what RAG is, just to cover basics if someone is new. So in a typical system, we generally give a query to an LLM and expect an answer. The LLM basically answers with its own internal trained knowledge. In RAG, in addition to the query, we provide the LLM with the necessary context required to answer the question. So how do we provide this context? There could be various ways we can provide the context. Using long context, you could input the whole document to the model, or you can use tool calls to input this context, or a common pattern is also to use the vector database and retrieve the relevant context and use it and use that to give it to LLM. So how does this works? There are basically two phases, I would say, a setup and storage phase and then a retrieval phase. In the setup and storage phase, you're basically collecting all the necessary information and documents that are required to complete the task and segmenting these documents into manageable chunks depending on the model that you choose, and passing that to an embedding model and creating the vector representation of these smaller chunks and storing that into your vector database. So that's the storage phase. And then in the retrieval phase, which is more real time, so whenever a user queries, so whenever a user queries, so a function basically does a similarity search and retrieves in the vector space and retrieves the relevant rows from the vector database and gives these chunks as a context to the model. So this is a typical RAG system. So now how good your model and your system works in RAG is basically depends on how good is your context that you provide to the model, right? So RAG works really well for a lot of use cases, as you all know, but it can also get quite complex quite fast. You might run into complexities like this, where as you're segmenting the documents into smaller chunks, the context can often get lost within these chunks. It may not carry over the full context that is in the document, and the document could include images, charts, graphs, things like that. And it could also be just a complex task where you need to provide context from multiple sources, or it could include like multiple rule calls. So for complexities like this, there exists like solutions. So I'll talk about contextual chunking in the next slide with an example so it's clear. For complex documents that include images, we can use multimodal RAG. So this is nothing but a pre-processing step where you're using a multimodal LLM like Maverick and converting the images into the text format, and basically using everything as if it's just a text document. And if you require context from multiple sources and tools, we can use agentic RAG. Go ahead.
Images that we may have?
Yeah, so in general, the model is able to understand the images. If you have specific like architecture diagrams, because that can vary, and if the model is not doing well, we might need to fine tune the model to work for that specific use case. Prabhu here can add more context.
No, I would love to actually answer your question outside so she can finish it, but happy to answer the question, yes.
Yeah, so if you need, if the model needs to get context from different sources, then we can use agentic RAG. So the agents basically can coordinate and handle retrieving from different tools or different databases to retrieve the necessary context. So for all of this, there are recipes in Llama cookbooks, and agentic RAG is really well supported on Databricks too. So I highly encourage looking into tools like this. So let's dive into contextual chunking now. So I want to highlight this because this is a community contribution from webapi.ai. I also encourage you all to make such contributions to help the open source community. So looking at the example here, so the chunk 1 basically talks about BMW X5 popularity and locations, and chunk 2 talks about BMW X5 pricing, right? So if you look at chunk 2 without chunk 1, would you know what it's actually referring to? You may not. So because as we segmenting the documents into smaller chunks and storing and treating these chunks as if they are independent, so this could always be a problem at the retrieval phase. To solve for this, what we can do is preserve the context of the chunk relative to the whole document with few keywords. something like this. So we are extracting the context of the chunk relative to the whole document and adding that to the chunk. So for example here, with chunk 1 we are adding BMW X5 locations, and with chunk 2 we are adding BMW X5 pricing. So now if you look at chunk 2 just by itself, you would know what it's actually referring to. So just with a simple technique like this, they're able to achieve a performance gain, almost doubling its performance. So yeah, I hope techniques like this really help you to solve for the knowledge problem. So now let's dive into the next set of issues that developers usually face. So this is generally where you're not getting the right format or the style from the model, or you need to improve the model's ability to adapt to your new or unseen information in a specific domain, or the model is not reasoning well for your specific task, right? So all of these are a set of issues where you need to improve the model's ability to, where you want to change the model's the behavior or the way it acts, right? So we can call this the behavior problem. So how do we solve for a behavior problem? Through fine-tuning. So fine-tuning solves for how the model needs to act. It helps adapt to your domain, and especially for your unique data sets and use cases. So here are some of the use cases where we have seen lot of success with fine-tuning. For example, teaching reasoning to the model specific to your task, and matching the performance of a larger model with a smaller model. This is like distilling from for example, if you want to match the performance of a 70B model with an 8B model, and finally adapting to the specific domain task. So this has been very common across all enterprise use cases and across different domains, healthcare, finance, retail, etc. So to fine-tune, there are many platforms which offer fine-tuning APIs. Here I'm showing the Databricks GenAI SDK. So all it takes is the target model and your training data set, and helps you to easily fine-tune the models. And Meta also publishes the recipes for, especially for the newer models, if you want to have fine-grained control over how you want to fine-tune the models. However, the challenge for fine-tuning is not fine-tuning itself, but having the high-quality data. So ideally, you need data that reflects how the model needs to behave in the real world across different scenarios. But in reality, the data is often fragmented, or it has gaps, or it is skewed. So if that's the case for your use case, I highly encourage using synthetic data generation tools. I'm showing two synthetic data generation tools here. One is open source by Meta called Synthetic Data Kit, and the other one is Databricks Synthetic Data API. Both of these tools work very similarly. They both take in context from the user and any documents or examples of how you want the synthetic data to be generated, and the tools basically output a well-curated data set that doesn't have PII that you can readily use for fine-tuning. And this is also very cost-effective. So here is a great example of how you can use synthetic data generation and fine-tuning to get amazing performance. So here we want to improve the model performance on tool calling. So we are taking a tool calling data set and enhancing the data set with chain of thought reasoning. And once we fine-tune the models, as you can see, we are able to achieve 6 to 13% improvement on the BFCL benchmark. BFCL is one of the popular benchmarks for tool calling. So before we part, I want to leave you with a cheat sheet for how to build with LLM apps. So step 1, build a proof of concept, an end-to-end prototype. Second, design an eval. This is a critical step that most developers and enterprises don't take seriously, but it's really important to design your test data set so very well, and also with the metrics that you care about. Establish a baseline performance with the prototype that you have built. And once you have a baseline, optimize with the prompt ops tool. So, and to further optimize for performance, first identify the problem. How do we identify the problem? So take some samples from the model output and analyze if the issue is because the task is just too complex. Are you asking the model to do too many things? If that's the case, break that down into specific tasks and use task-specific agents. And if the issue is because you expect the model to know something, but it's not returning a factual answer, so in that case, use RAT techniques that we talked about. And if the issue is behavior, where you need to change how the model needs to act or how the model behaves, then use fine-tuning and leverage synthetic data generation to fill for those data gaps. And sometimes you may need the combination of all three of these depending on your problem identification and your analysis, right? Finally, don't forget to run the eval at each step of your optimization to ensure the optimization is moving in the right direction. So I hope some of these will be useful for your use case. Please take a moment and fill out our developer survey. Let us know how we can support you better, any specific recipes or tools that you want to see. Yeah, and also any problems that we didn't address today but you want to find solutions for, please let us know. Here are the links for the prompt ops tool and also Llama cookbook. Llama cookbook has recipes for a lot of things that we talked about today. Thank you.
Yep, just parting note, thanks all for showing up. Again, I think the message we want you to take away is that you can do wonders with techniques that are cheap. You don't have to spend a ton of money on proprietary stuff. Open source is the way. And then the second thing is Llama cookbook, we are constantly adding new recipes, new things. If there is something that you are struggling with, would love to see a recipe in a Llama cookbook, just drop it in the developer survey. We would love to be able to add stuff that can help all of you. So thank you.